Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC. A lifetime of hard work. Children laughing in the kitchen. Family photos on a restaurant wall. A legacy that lives on. It all comes from the power of a conversation. Like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
This is SpaceTime Series 26, Episode 85, for broadcast on the 17th of July, 2023. Coming up on SpaceTime, a possible retake on the age of the universe, a new look at the ringed world of Saturn thanks to the Webb Space Telescope, and Australia to grow plants on the moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggested the universe might actually be 26.7 billion years old. Now, if correct, that's nearly twice as old as the 13.8 billion year age previously believed. The new study, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, challenges the dominant cosmological model and sheds new light on the so-called impossible early galaxy problem. The study's author, Rajendra Gupta from the University of Ottawa, says his newly devised model stretches galaxy formation time by several billion years. Astronomers and physicists have calculated the age of the universe by measuring the time elapsed since the Big Bang and by studying the older stars, based on the redshift of light coming from distant galaxies. In 2021, thanks to new techniques and advances in technology, the age of our universe was estimated to be between 13.797 and 13.82 billion years, using the lambda cold dark matter concordance model. However, many scientists have been puzzled by the existence of stars like the Methuselah star that appear to be older than the estimated age of the universe, and also by the discovery of very early galaxies in the James Webb Space Telescope images, which appear to have already achieved an advanced state of evolution. These galaxies, existing just 300 million years after the Big Bang, appear to have already achieved a level of mass and maturity normally associated with galaxies billions of years older. Zwicky's tired light theory proposes that the redshift of light from distant galaxies is due to a gradual loss of energy by photons over vast cosmic distances. However, that conflicts with observations. According to Gupta, by allowing this theory to coexist with the expanding universe, it becomes possible to reinterpret redshift as a hybrid phenomenon rather than purely due to the expansion of space-time. In addition to Zwicky's tired light theory, Gupta introduces the idea of evolving coupling constants that was previously hypothesized by Paul Dirac. Coupling constants are fundamental physical constants that govern the interactions between particles. Now, according to Dirac, these constants could vary over time, meaning they're not nearly as constant as we think they are. By allowing them to evolve, the timeline for the formation of early galaxies as observed by the Webb Space Telescope at high redshifts can be extended from a few 100 million years to several billion. Gupta says this provides a more feasible explanation for the advanced level of development and the mass observed in these ancient galaxies. Moreover, Gupta suggests that the traditional interpretation of the cosmological constant, which represents dark energy and is responsible for the accelerating expansion of the universe, also needs revision. Instead, he proposes a constant that accounts for the evolution of the coupling constants. Gupta says this modification of the cosmological model helps address the puzzle of small galaxy sizes observed in the early universe, allowing for more accurate observations. Of course, this is all just a hypothesis, but it adds to a growing list of ideas to try and explain early cosmology. Although I myself still prefer the idea of time itself operating at a slower rate during the earlier stages of the universe's existence. But of course, none of this provides a satisfactory explanation for the cosmic inflation which must have occurred in the opening seconds of the universe. Temporal anomalies excluded. This is space-time. Still to come, a spectacular new image of the Saturnian system by the James Webb Space Telescope, and Australia to grow plants on the moon. All that and more still to come on SpaceTime. After recent observations of Uranus, Neptune and Jupiter, NASA's James Webb Space Telescope has now taken some time out of its busy research program to undertake a quick look at the spectacular ring dwarf of Saturn. The stunning new image shows Saturn's iconic ring seeming to eerily glow. The incredible infrared picture also unveils unexpected features in Saturn's atmosphere. The image serves as context for an observing program that'll test the telescope's ability to detect faint moons around the planet and its bright rings. Any newly observed moons could help scientists put together a more complete picture of the current system of Saturn as well as its past. Methane gas absorbs almost all of the sunlight falling onto the atmosphere in this image, which is taken at a specific wavelength of 3.23 microns. Now, as a result, Saturn's familiar stripe patterns aren't visible because the methane-rich upper atmosphere blocks out our view of the primary clouds. Instead, Saturn's rings appear dark, and we see features associated with high-altitude stratospheric aerosols, including large dark and diffuse structures in Saturn's northern hemisphere that don't align with the planet's lines of latitude. Interestingly, scientists also spotted similar features in the early Webb-NIRCam images of Jupiter. Now, unlike its atmosphere, Saturn's rings lack methane, so at this infrared wavelength they're no darker than usual and thus easily outshine the darkened planet. It provides an eerie view. The new image of Saturn also reveals intricate details within the ring system, showcasing several of the planet's moons like Dione, Enceladus and Tethys. Over the past few decades, missions like NASA's Pioneer 11, the Voyagers 1 and 2 spacecraft, and the Cassini mission, as well as the Hubble Space Telescope, have all observed Saturn's atmospheres and rings in exquisite detail. And this now adds to that database. Moving from the inner to the outer features of Saturn's rings are the dark C ring, the bright B ring, and the narrow and dark Cassini division, and the medium bright A ring with the dark Encke gap at its outer edge. Additionally, off the outer edge of the A ring is the narrow strand known as the F ring. The image shows the rings both casting a shadow onto the planet and vice versa, thereby creating some interesting visual effects. In-depth exposures will allow scientists to investigate Saturn's rings further, including the thin G ring and the diffuse E ring. Saturn's rings consist of an assortment of rocky and icy fragments, ranging in size from chunks as large as mountains to tiny fragments less than a grain of sand. Recently, researchers used Webb to explore Enceladus and discovered a substantial plume emanating from the moon's south pole. The plume contains particles and copious amounts of water vapor which contribute to forming Saturn's E-ring. The observations are also showing seasonal differences between Saturn's north and south poles. It's currently summertime in Saturn's northern hemisphere, while the southern hemisphere is emerging from its winter darkness. However, the northern pole still appears unusually dark. That could be due to some sort of unknown seasonal process affecting polar aerosols. A faint brightening of the edge of Saturn's disk might be attributed to high-altitude methane fluorescence, or it could be emissions from the ionosphere's trihydrogen ions. Spectroscopy from Webb could help to resolve the issue. And if you want to see the images for yourself, just go to the SpaceTime website. This is SpaceTime. Still to come, a new Australian experiment to grow plants on the moon, and later in the science report, planet Earth experiences its hottest week on record. All that and more still to come on SpaceTime. .
Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC. This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Australian scientists have announced a bold plan to grow seedlings on the moon by 2026. The Australian Lunar Experiment Promoting Horticulture, or ALIF project, which is being funded by the Australian Space Agency's Moon to Mars initiative, is designed to develop a greater understanding of horticulture in extreme environments. The joint project, involving the Royal Melbourne Institute of Technology, the Queensland University of Technology, the Australian National University, and Israel's Ben Gurion University, is investigating whether seedlings can grow on the lunar surface. The experiment is of fundamental biological interest and importance for future manned missions to the Moon and Mars. If we ever want to set up colonies on these worlds, we need to learn how to survive there, independent of the Earth. The project's co-founder and engineering lead, Dr. Graham Dorrington from RMIT, says the seeds and plants will be transported in a specially designed and hermetically sealed chamber, equipped with sensors, water and a camera, and mounted aboard a lunar lander slated to launch in 2026. He says the biggest challenge in designing the chamber involves maintaining stable conditions inside it in order to permit germination on the lunar surface, where external surface temperatures fluctuate from highs of 80 degrees Celsius down to lows of minus 180 degrees Celsius. And of course, the chamber also needs to be really lightweight, no more than 1.5 kilograms, and it needs to be able to operate on minimal power while transmitting data by way of the lander back to Earth using data rates of less than 40 kilobits per second. Dorrington says these are all considerable challenges. Previous and current experiments in low Earth orbit are showing scientists that some plants grow differently in microgravity conditions. However, it's been difficult to work out exactly why that's the case. Furthermore, the harsh lunar environment, with its thin exosphere, rapidly changing temperatures, and relatively poor soil properties, mean that whatever humans grow on the lunar surface will need to be hardy. One of the plants being considered for the mission is rapeseed, a yellow-flowered plant grown for a range of food production and industrial uses. Preliminary results suggest that this could be a good candidate in terms both of extreme temperature tolerance and germination speed, needed for surviving a mission to the Moon or Mars. After landing on the lunar surface, the plant's growth and general health will be monitored and the data and images sent back to Earth. RMIT will also be contributing computer science expertise for data compression to enable this part of the mission. And citizen scientists and school kids around the world will be invited to participate, given the data as it comes in, so they can conduct their own experiments to see which plant varieties have the best chance of growing on the Moon.
When you take an experiment up to the ISS, it's really in shirt-sleeve conditions, if you think about inside the ISS. There are having experiments done outside the ISS, but most of the experiments are done inside in shirt-sleeve conditions. But on the lunar surface, of course, the surface temperatures are highly variable, and you've got a limit if you've got that payload on a lander, you've got to deal with that thermal swing. Also on the transit to the Moon, there's very little opportunity to control the temperature with very little power, so you have quite big temperature swings on the way to the Moon. The radiation environment's slightly worse. Well, we don't know exactly what the conditions be. It depends on the time of landing and what's happening with Solar 25, but it's going to be slightly higher, the radiation levels. which may be slightly different than the ISS, but not tremendously. And of course, the major difference is that it's at 1/6 gravity. So there have been centrifuge experiments done at 1/6 gravity, short periods of time on the ISS. But most of the ISS experiments, of course, are done in microgravity, where there's all sorts of different responses, phototrophic responses to the plants. So that's all well understood, but very little data on what would happen at 1/6 gravity.
These will be seedlings when they go up, I take it?
The biology team have got, at the moment, very many varied opinions about how that should be done and what should be carried. So, in fact, one of the types of plants that are considered to be so-called resurrection plants, which are not seedlings, but they'll be small, but they're already grown, and then the aim is to resurrect them on the lunar surface. But if it is seeds and seedlings, it will be ones that have to germinate within a relatively short window. We're expecting the lander to be down the surface soon after lunar dawn. And then we've got a limited window, and that depends on the inclination that's finally picked for the lander, probably around 55 degrees, we don't know yet. That inclination will affect the temperature, and the temperature rises, and then we have to manage that. So we think we've got a limited window at 72 hours.
You can't just plant them in the soil. What's the proposal?
The proposal is to put some plants or seeds in a small chamber. It's about the chamber total volume is quite small. It's about 200 millimetres by 100 millimetres diameter, and only weighs 1.5 kilos. And that chamber will have air in it at 1 bar. And our aim is to germinate the seeds or add water to them and make them grow on the lunar surface for a limited period of time. We'll have a period of about 72 hours in which to demonstrate we can do this. And in that time window, we've got to keep the temperature in the chamber within quite constrained bounds, around 25 degrees centigrade, when the lunar surface temperature will be changing more widely.
You're in an environment where temperature swings will be quite dramatic. You'll be there in the daytime, so it's going to get awfully hot.
It'll be inside the lander. The landers cover what we call multi-layer insulation, so it doesn't really matter its orientation because the bulk temperatures will be the same inside. But that is going to be a challenge. The actual orientation of the lander relative to the sun at dawn will be a factor in our thermal calculations. That's an important one, yeah.
Because it's only 72 hours.
Well, that's the window we're sort of guaranteed. The lander's battery has got a limited life, but we're actually hopeful it'll be extended longer than that. And actually, if we have a landing at 55 degrees, we think that the actual peak temperature reached by our payload will be not too large, and we think we can probably actually extend that to possibly, well, it's not clear, but possibly as much as 10 Earth days. So that's the longest window we've got. The objective is to achieve the mission, as it were, and demonstrate plant growth and get the photographs of the plants within those 72 hours.
And so there's this chamber. I guess it's sort of like a terrarium in a way.
Yes, we call it a lunarium.
Fair enough. A sealed environment. Plants breathe CO2 and breathe out oxygen, so I guess you don't need to supply extra oxygen at this stage. You will need to provide light, but...
Well, because we're doing such a small mass of seedlings, the actual volume of air in there is sufficient for that period, so we don't need to add extra CO2 or whatever. And also, some plants do germinate in the dark, of course, but we will be using LED lighting like we do in the ISS, and that's also still debated in the team whether we use, what frequency we use.
That'll depend on the plant, won't it?
Depends on the plant, and it's usually a mixture of red and blue, and particular frequencies is considered to be quite good, and all the people doing vertical farming are doing that.
The plants will be surviving on their own built-in supplies of food. You won't be adding nutrients to the soil, I take it?
Well, no, some of the biologists want to look at, say, growth accelerators and things like that. So, again, the choice of species is going to be quite interesting, and there's an interest in sea tolerance to arid and conditions and hot conditions, and that is a sort of spin-off of the project, if you like, a research spin-off of how we can make these plants more tolerant to adverse conditions. So that could be the way the seeds are treated or the way the substrates were used.
And then there's the issue of water. Will they need watering during that time, or will the soils be moist?
What's interesting is seeds are very tolerant when they're in the desiccated state, just like the resurrection plants. They're very tolerant to extreme conditions when they're desiccated state. But in order to germinate, you have to release water. We have a valve and we release the water onto the plant, and then they're quite sensitive to their conditions. They become much more sensitive, particularly temperature. So yes, we will have an event where we add water to the plants. That's a key event in the sequence. It'll be, of course, all sort of basically pre-programmed.
So all this will be a self-contained package. Will it have its own power supply, or will it be drawing power from the spacecraft?
We're just drawing another challenge. We're drawing power from the spacecraft. We're limited to an average power of about 2 to 3 watts.
Yeah, there's a budget there, isn't there?
There's very much a budget on that, yeah. And we have got some power on transit as well to the moon, which is also very useful. That helps us solve a lot of the problems, particularly getting too cold.
And the other issue you'll have, of course, will be lunar radiation. We don't have an atmosphere or major magnetic field on the moon, so consequently these plants are going to handle some degree of radiation?
Well, again, that's an area that hasn't been well looked at, but we've got built into this project a test plan with ANSTO and the accelerator ANU, which is capable of firing quite high energy protons. We plan to put some plants in that chamber and see how they respond. It turns out the plants are quite good at DNA, at radiation tolerance. They seem to be able to almost self-repair, some of them, so that's quite an interesting aspect of the project. So look, in this particular mission, 72 hours, it's not going to be a major issue, but it's of academic interest as well for the future, whether plants can tolerate these high radiation levels.
Yeah, because when you're growing plants on the International Space Station, apart from one or two orbital locations, such as the South Atlantic anomaly, you're still protected by the Van Allen radiation belt. So the radiation doses will be very different once you're on the far side of that. Yep.
Well, there'll be high energy particles. And I said, if this soon after the solar 25 peak, we're expecting that to be an issue, also for the electronics, by the way. So we're doing testing on the electronics as well. But look, I think that makes it interesting, and that I don't think it's such a major problem, to be honest with you, because plants seem to be much more tolerant to radiation damage. And why that is interesting itself.
You'll be monitoring this thing live as it unfolds, or will you be limited in the amount of bandwidth you get to?
We're very limited on bandwidth. Look, we've also got the dish. They've agreed to allow us to use the dish under commercial basis, so we'll be able to download using that. But even so, we're limited on bandwidth, maybe down to 40 kilobytes per second. So we're actually only planning to send back periodically pictures, not video, of the plants as they grow. And even then, you need to use data compression.
Learning all this will help with what? The idea of establishing human colonies on the moon and eventually Mars?
That is a view that people take. That is, it could be useful information for development of closed life support systems in the future. There could be hundreds of years from now, generations beyond us, that they could be happening. But I think primary interest in doing it is to demonstrate, just to find out what happens, just to do the experiment.
You don't want to be taking your food and water with you once you start sending people to the moon and Mars if you don't have to. If you can grow stuff in situ and get your water in situ through reclamation, and they're doing that now on the ISS. I think 98% of the water they drink now is recycled.
Very little food is grown up there.
True, yeah.
And for the near-term Artemis mission,
they've had some
they'll carry. Yeah, I think near-term Artemis it will be pre-packaged food, of course. Yeah, there's a strong argument in general that in the future in situ resource utilization is going to be used because it's so tremendously energetically expensive to take something from the Earth through our gravity well to space or to the moon. It's much easier to get stuff from the lunar surface even to Earth orbit in terms of energetically. So you can argue that there's going to be a lot of in-situ resource utilization in the future.
And we're seeing that here on Earth too, aren't we, with vertical farming becoming more and more popular in some crowded cities?
I think so. And it's a very much a growth industry. And I think you'll see more and more people kind of doing using micro units to grow microgreens. In fact, one of our partner companies, Micropod, markets a product which I've been using, and where you grow seedlings at home. And that's been an eye-opener to me as an engineer to get involved in that. Our seed mission is just a sort of small attempt to get a payload, just a functional payload on the moon and demonstrate something. And the primary purpose was really for education. I should have said that we were trying to inspire the next generation. And so what we want to do is basically go out to schools and say, hey, what seeds would you grow on the moon? And let them make their own terrariums and experiment, and then have a website where we show our lunar terrarium or lunarium with what's happening, our ground-based analog experiment 1G, and their experiments. So they kind of participate in it rather than just being bystanders to the event. Do you see what I'm saying? It's kind of
more
we're trying to make it
more information. Yeah.
Yeah, exactly. Yes, and we're trying to involve schools. School teachers. In time, we'll get this organised, and we'll try to get this sort of community going where everyone's more inclusive. We're trying to make it much more inclusive. In effect, encourage citizen science. But the real motivation there is to try and use that next generation take an interest in this whole domain. So encourage them into this area.
That's Dr. Graham Dorrington from RMIT, and this is SpaceTime.
This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation. Like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC. This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The world has just experienced its hottest week on record. Early data from the World Meteorological Organization and NASA indicates the first week of July was the hottest globally since records began. It comes after the hottest individual days on record last week and the World Meteorological Organization's declaration of a new El Niño event. The World Meteorological Organization says these records are coming despite some areas, including Western Australia, the Western United States, and even Western Russia, recording cooler than normal temperatures throughout June. The observations also show Antarctic sea ice was at its lowest extent for the month of June since records began. The record-breaking temperatures on land and on the ocean have potentially devastating impacts on ecosystems and the environment. They highlight the far-reaching changes taking place in the Earth system as a result of human-induced climate change. Meteorologists say that humans are in uncharted territory, and we can expect more records to fall as El Niño develops further, and these impacts will extend well into 2024. According to provisional analyses based on a reanalysis of data from Japan named JRA3Q, average global temperature on July the 7th was 17.24 degrees Celsius. That's 0.3 degrees Celsius above the previous record of 16.94 degrees Celsius recorded back on August the 16th, 2016, and that was also a strong El Niño year. Scientists in the US have published research on the creation of embryo models from stem cells in order to mimic the developmental processes that occur in early human embryos. The details, released in the journal Nature, follow a flurry of reports about similar research over the last few months by other groups, which has been provided to the International Society for Stem Cell Research's annual meeting in Boston. The authors created models of embryos from stem cells showing how it already resembles the human embryo at days 9 to 14 after fertilization. But they say because the embryo lacks the cells that are involved in the development of the placenta, they cannot become a fetus. They say their system provides a reproducible and easy-to-control platform to understand the basic mechanisms that underlie human development, including new ways to examine developmental issues. Scientists are hoping to make the world's first safe and efficient, non-toxic, aqueous aluminum radical battery. Most batteries contain hazardous materials, including lead, cadmium and mercury, which all pollute the environment once they're disposed of. The new research, reported in the Journal of the American Chemical Society, looked at the electrochemistry of stable radicals. Stable radicals are a class of organic electroactive molecules that have been widely used in different organic battery systems. The first design of aluminum radical batteries, which use water-based electrolytes that are fire retardant and air stable, are developing a stable 1.25-volt output and a capacity of 110 mAh per gram of mass, 1 over 800 cycles, with only a 0.028% loss per cycle. Multivalent metal-ion batteries, including aluminum, zinc and magnesium, use abundant elements in the Earth's crust and provide much higher energy density than lithium-ion batteries. Aluminum-ion batteries are attracting attention because aluminum is the third most abundant element, which makes it a potential sustainable and low-cost energy storage system. However, one of the major challenges for current aluminum-ion batteries is the low cathode efficiency. Organic conjugated polymers could address the ion transport issue, but their battery voltage output performance remains poor. You know what's really weird? How the dog or cat always know when they're about to be taken to the vets. You don't have to say or do anything. They just know. And it's not like you're doing anything different from when you're going out, going to work or going to the store and you get those big sad eyes. You're leaving me. I'll never see you again. Please don't go. But when it's a vet appointment, they're gone. They're nowhere to be found. And have you noticed it's the same when you try to give them their medicine? They'll eat any disgusting, rotten piece of food they find on the ground. But you try to give them the best chunk of fillet steak with a pill hidden in the middle, and all of a sudden they're Gordon Ramsay. A new survey claims that 80% of British dog owners have seen this behaviour in their pets, and they believe it's a sign of psychic abilities. Tim Mendham from Australian Skeptics says it's a sign of the paranormal.
Of course, we all know that the Brits are very keen on their pets, especially dogs. So this organisation that does dog walking, that sort of profession, did a survey and they found that 8 out of 10 British dog owners think their pet has psychic powers. In fact, 65% say that they let their, what they describe as paranormal pooch, they allowed them to make decisions for them. Like, this is some often life-changing decisions. And yeah, sort of dogs and things and cats, some pets are going to be very sensitive to environments and things. But I wouldn't necessarily ask them to make decisions about them. For instance, 14% of these owners said that they'd allow their dog to sniff out an unsuitable partner. Maybe they smell, I don't know. 9% said that their dog can pick a sports result. And 7% even say that they use their animals to investigate marriage proposals and job offers. They don't follow that up to see if they actually got married or got the job. But there's a lot of statistics that came out of these things.
Zero to both.
Yes, they surveyed 1,000 people through an online network of pet sitters and dog walkers. So there are people who are committed already to animals, but they have a lot of exposure to
things
animals.
that animals can do. They do pick up seismic waves in the ground before earthquakes. They do sniff out chemicals which people emit in the process of dying. So there are these things, these stories of a dog or a cat who will sit with somebody who's going to die that night. That's true, that happens. But there's a reason for it. There's a scientific reason behind it.
Yes, dogs are very sensitive with their smells. They can pick out, as I say, the chemicals emitted, also for cancer cases and that sort of stuff, supposedly as well. So, I mean, there's a
COVID-19 test now.
There's a role of animals in this case, but I wouldn't use it for checking out whether you could marry someone, right?
No.
This survey was very comprehensive, asking a lot of questions. They say that 25% of people trusted their dog more than their partners or even themselves.
Well, I can understand that.
Yeah, so it's an interesting. They let the dog choose how they're going to go for a walk, where they're going to go for a walk. That's perhaps you don't have the other way. That dog will take you. The dog will choose what to eat.
Yeah, but then again, dogs will smell out bad stuff in foods.
Yes.
They'll see things in the distance that are dangerous, and that's why they'll get you to walk the other way.
All logical explanations, yes, but not for all these things. I don't know if a marriage proposal or an unsuitable partner is the thing that a dog can smell. Maybe it is. Maybe you say a very smelly person is not suitable as a life partner. But there's a lot of stuff that they say that they allow their dogs to choose, even down to sort of picking the Eurovision Song Contest. As they said, there was a dog that picked the outcome of the Eurovision Song Contest. Well, there's only so many players in the Eurovision Song Contest. I'm sure there's a dog that picked out the winner. Doing it reliably is a bit of a hard thing, as we have found out when looking at all the animal predictions.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation, like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.